Hey you guys, welcome back to geometry. This is going to be our fifth set of notes in Unit 7. So this is going to be our 7.5. And today we're going to be talking about rectangles. So rectangles have the same properties of a parallelogram, okay? So a rectangle is a parallelogram. It's a type of parallelogram, except we have two added properties, okay? So just to recap, a parallelogram has opposite sides that are congruent, opposite sides are parallel, opposite angles are congruent, and consecutive angles are supplementary. Diagonals bisect each other. Great, those all make sense. We've gone over that. The two added properties is that all four corners, I should say, not angles, make a 90-degree angle. Okay. Now, the other property is that the diagonals are congruent. Okay. So if we take a look at number 1, okay, and we try to fill out the information, well, number 1 asked us, what is QR? Well, we know that a parallelogram has congruent opposite sides. So if this side is 10, then the opposite side is also 10, right? It's congruent. Same thing with SQ. The opposite side of SQ is 24, so SQ must also be 24. Okay, now they're asked, SR is 24. Now they're asking for SQ. SQ is going to be this diagonal right here. And in order to find the length of a diagonal, we have to be able to find a right triangle. And we know we can always find a right triangle when dealing with rectangles because each corner is 90 degrees, right? So if this is a 90-degree corner, then we have a 90-degree angle in a triangle, which makes it a right triangle. And if we want to try to find this side is called the hypotenuse, right, of this right triangle. And in order to find the hypotenuse, the length of a hypotenuse of a right triangle, you might remember from past units that we are going to use the Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared equals c squared. And if a squared is 10, then we'd say 10 squared. Then b squared would be 24 squared. And it equals c squared, right? And so we don't know what c squared is, so we're going to solve for c. So 10 times 10 is 100. 24 times 24 is 576. And then we bring down our c squared. We're going to combine our like terms, so that would be 676 is going to be our left side of the equation, is c squared. And if you don't remember, in order to get c by itself when there's a squared symbol, you're going to do the opposite of that, which is actually the square root. And whatever you do to one side, you do the other side. So 676 squared, the square root of 676 is going to be 26. So 1c equals 26. So we were able to find this hypotenuse. SQ is going to be 24. Now they're asking for PR, which is the opposite or the other diagonal. And remember that both diagonals are congruent, right? So if SQ is 26, then PR is also 26. Now we're asked to find QT. And if we're looking for QT, it's going to be just this portion, right? And we know that according to a parallelogram that diagonals bisect each other, meaning that this diagonal is being cut in half at the point T. So we have to find half of the whole length, which is 26, and 26 divided by 2 is 13. So half of this diagonal is going to be 13. All right, you guys, let's look at number 9. So they tell us that VW is 9x minus 1. I'm going to write that first. 9x minus 11, I'm sorry, not 1. Then they tell us that SU, which is this whole length, is 16x minus 12. Find WT. So I'm going to make WT blue. So they want us to find this length right here. Well, if we think about the properties of a parallelogram, of a rectangle, well, for the rectangle, we know that the diagonals are congruent. Okay, so we know that it's also, the point in the middle is a bisector, right? It's bisecting each diagonal into two congruent parts. So if I think about WT, which is this right here, I know that WT is going to be congruent to VW, since VW is the same length of WT because there's a bisector, right, cutting it in half. So if I can find this length, VW, then I already know that what WT is going to be because they're congruent. Well, let's think about how are we going to find the length of VW? Well, according to our properties of rectangles, these diagonals are congruent, right? So I can say that SU equals VT, or I can say that SU equals 2 times VW. And we know that because VW is only half of the length of the whole VT. Okay, so why don't I go ahead and plug in my equations into this equation to solve. SW is 16x minus 12 equals 2 times our VW, which is 9x minus 11. I'm going to distribute my 2, which is 18 minus 22, 16x minus 12. I'm going to bring my 22 to the other side, and that will give me a positive 20, and this will give me a positive 2x. Then I know that x equals 5. Okay, so I found out what the value of x is. Now all I need to do is plug it back in to VW, since we've already established that VW is the same length as WT. So I do 9 times 5 minus 11. So I have 45 minus 11 is 34. So the length of VW is 34. And the length of WT is also 34 because these two are congruent. All right, let's take a look at number 13. Okay, something I just want to talk about is that all of these triangles inside of our rectangle are isosceles triangles. What does that mean? Well, from last year, another quarter unit that we've done, when we talk about an isosceles triangle, these two lengths right here are congruent. And whenever you have two of your legs that are congruent, the base angles are also congruent. Okay, just a reminder of the properties of an isosceles triangle. We know that all of these, right, this side is congruent to this side, and this side is also congruent to this side, and all of them are congruent, right, because the diagonals are congruent, and this bisector is cutting in half two congruent diagonals. So if they say that this is 10, then this is also 10, this is also 10, and this is also 10. Okay, and that matters because when you're trying to find the angle, a measure of an angle, you need to remember that the base angles are congruent of your isosceles triangle. Okay, so if this is 5x plus 7, this is also 5x plus 7. Okay, Now, these triangles are the same. This also would be 5x plus 7, but we don't need to work on that side of the triangle or of the rectangle because we just need to solve this x here. What we need to do is find the angle on this side. Okay? If we know that this angle is 50, then we can say, okay, well 50 plus 5x plus 7 plus 5x plus 7 equals 180 degrees, right? All three angles within a triangle is 180 degrees. So let's try to find the measure of this angle right here, and then we can set up our equation. Okay, this is a line. So if these two angles are being shared on a line, then we know that they both add up to 180 degrees. So we take 180 minus 134. Then we are going to solve that. So that would mean that this side of the angle is 46. Now I can set up my equation so that I can solve for x. Remember, all three angles add up to 180. So 180 equals our first angle, which is 46, plus our second angle, which is 5x plus 7, and our third angle is also 5x plus 7. Let me make some space, clean this up a little bit. Okay, I'm going to combine my like terms. I have 7, 7, and 46. So 14 plus 46 is going to be 60. So I'm going to take 60, right, and subtract it from both sides. Sorry, I should do it down here. Okay. So now I have a 120. So I was able to take care of my 7s and my 46. So now I have 120 equals 5x plus 5x. Well, that's going to be 10x. Divide by 10 on both sides. So now I have x equals 12. So I just solved for x.